We're going to begin with what is the most important part of algebra that you're going to be working with or learning is factoring. So we're going to start off nice, easy baby steps. So far with polynomials, we've done addition, we've done subtraction, and we've done multiplying with the double distributive property. Factoring is a form of division. It is actually our double distributive property backwards. So it's the inverse of the distributive property. So what I want to do, since the distributive property is multiplying, I want to see what is the greatest common factor. So what can I divide out of our two terms? So we're working with a binomial right now since it has two terms. And I want to know what can I divide out from both of these terms. So I'm going to look at the coefficient. So that's the number out in front. So I have a -3 and a +9. Well, the value of 3 divides into both -3 and 9. I never want my leading coefficient to be negative though, so I'm going to divide each of these terms by -3. That way our front number becomes positive. Okay, but 3 is the GCF for our coefficients. Now I'm going to look at the variables. So I have x squared, which means I have two x's that are being multiplied, and then just x to the first power, which is just x. So if my first term has two x's and my second term only has a single x, that means I can only divide out by 1x. It's like having a bank account and you only have $1 in it. If you only have $1 in it and you take out $2, all right, you're going to be charged because you took out more money than what you have. So usually the GCF for the variable is always going to be what the smallest exponent is. And even if there's no exponent, that means you can't take out any variables at all. So our GCF is -3x. Since this is the reverse of the distributive property, that means the -3x is the multiplier out in front. So that value comes to the front, and then our division goes inside of the parentheses. So if we think of this in terms of our lifeguard jumping into the pool, this factor, this divider, is our lifeguard. We're finding who the lifeguard is. So I'm going to divide. -3 divided by -3 is 1. X squared divided by x. So that's like having two x's up top, and I'm dividing by an x on the bottom. So one set of x's will cancel, and I'm left with 1x. So x squared divided by x, I actually subtract 2 minus 1 is 1. Then I'm going to divide by my second term. 9 divided by -3 is -3. This time I have 1x up top, 1x on the bottom. They completely canceled, so I don't have any variables. So my final factored form is -3 parentheses 1x minus 3. I can always check my work because if I were to distribute this through, so I multiply through, I would get -3 times x is -3x to the second. -3 times -3x times -3 is +9x. And I'm back to my original problem. So we found the distributive property. That's what factoring is going back to the form where we can distribute to get back to the original polynomial. So for this example, we got to first start by finding our lifeguard, finding the greatest common factor. So looking at our coefficients alone, we have 4 and -10 or 10. Our front value is positive, so we don't have to divide out by a negative. So what's the biggest number that goes into both 4 and 10? And that is 2. For our variables, we have 4 x's for our first term and 2 x's for our second term. Remember, it's easiest to think of this as whatever your smallest variable is, that's going to be your GCF for the variable portion. So since my front one has 4 and my second one has 2, that means I can take out 2 x's from both and not go into debt. So my divisor is x squared for the variables. So here's my lifeguard. So that's what's going to go out in front of my parentheses is the 2x squared. And then I have to divide to get the inside of my parentheses. So 4x to the fourth divided by 2x to the second. 4 divided by 2 is 2. If I had 4 x's, but I'm physically taking 2 out, I am left over with 2. For my second term, I have negative 10 divided by 2 is negative 5. If I had 2 x's and I'm taking 2 out, I don't have any x's left over. So this is my final answer. Where we're going to be heading with this week is we want it to be in factored form. So we are going to figure out a method to get our 2 set of binomials or our double distributive property down to 2 binomials. So if you recall, when we did this before, we would double distribute when I asked you to multiply. So first term times first term, we have x to the second. First times that last is 3x. Our second term times the first is 2x. And our last times our last is 6. Then we always combine last like terms in the middle. So I'd end up with x squared plus 5x plus 6. So we're going to be starting with the trinomial. And our goal is to work backwards to get to the double distributive property. So there's some things that we need, or characteristics that we need to look at. First, our first multiplication is going to match the first term in our trinomial. So x squared matches x squared, which is our first multiplication of x times x. The last term matches our last multiplication. So we had 6 was our constant, and that matched our last multiplication of 2 times 3. The one that's a little bit trickier to get is that value in the middle of 5x, because 5x is a combination of 2 terms. It's the combination of our like terms, and I'm going to refer to that as our inners and our outers. So it's a combination of multiplying 2x and multiplying 3x, which gave us that inside term. So where we're going to be heading to this week is we want to break down this trinomial into the double distributive property. So my first 2 values need to multiply together to get x squared. Thankfully, there's only one option, x times x. The last 2 terms need to multiply together to make 12. Now, unfortunately, there's some options. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. We have to pick out the correct combination so that when I multiply my inside numbers and my outside numbers, they combine together to make 7x. So I'm just going to randomly pick 2 times 6. So I'm going to plug in 2 and 6, which is nice because I do know that 2 times 6 will give me that 12. But I'm going to check my inners and my outers. So my inside term, 2 times x is 2x. X times 6 is 6x. When I combine those together, I get 8x. I wanted 7x. So 2 and 6 is not the correct combination. So I'm going to try another combination. I'm going to go with 3 and 4 this time. So I'm going to check my inners, outers. 3 times x is 3x. X times 4 is 4x. When I combine my like terms, I do get 7x, which is exactly what I wanted to get. So my factored form is x plus 3 times x plus 4. I can always check my work by doing the double distributive property, and I will get back to my original trinomial.